Hi ladies, this is Miss Loden. This is section 1.4, problem number 6, graph sequences of transformations. I want to make sure that you notice that when you graph more than one transformation at a time, it's important that you follow this order. Horizontal shifting first, then stretch and shrink, reflecting, then vertical shifting. I like to list the transformations before I start making them. If you'd rather not do that, that's fine. But I think it's helpful to list the transformations. So first of all, our first transformation, timeout. If you notice, inside parentheses, x minus 1 tells us there's a horizontal shift. Remember, horizontal changes are in the opposite direction, so the minus 1 tells me I want to shift right 1. Outside parentheses is the 1/2 times the function, so that tells me that it affects the y coordinate only, so I will multiply 1/2 times the y coordinate. And those are the only reflections for this example, or the only transformations. So I'm going to come over to my function that's been drawn here for us, and I am going to highlight the points. I'm going to highlight the beginning, the first point. I'm going to highlight the final point, and I'm going to highlight every time a direction changes. And these are the points that I'm going to move for my transformation. So purple will be the final point. I'll begin by moving this ordered pair right 1, and then I will multiply its y coordinate by 1/2. The y coordinate is 0, and 0 times 1/2 is 0. I perform 2 transformations with that point. Let me make that smaller. Okay. Then I'll take the ordered pair -1, 3. I'll move it right 1. The y coordinate is 3. 3 times 1/2 is 1.5, so I'll move it to 1.5. So notice that when I multiply the y coordinates by 1/2, they are shrinking. Go to my third ordered pair, I'll move it right 1. Its y coordinate is 0, and 0 times 1/2 is 0. And finally, the last one is the same situation, right 1, 0 times 1/2 is 0. And from there, I'll connect. And here's our transformed function. With example B, I notice that I have 3 transformations. Transformation number 1 is inside parentheses. It's +2, so that's a horizontal shift to the left. So we'll travel left 2. Transformation number 2 is the negative being multiplied by f of x. Remember, that's a reflection. That's a that's a vertical reflection because the negative is on the outside. Vertical means that we will reflect across the x-axis. So reflect across x-axis. And then the third is the -1. That's a vertical shift, so we'll go down 1. All right. Again, I'll select 3 points, not 3. I will select the beginning and then where directions change. In this case, that happens to be 4 points. And then with the purple color, I'll make all the transformations. So I'll begin by moving each point left 2. I'll reflect across the x-axis. When a point is on the x-axis, there is no reflection, and then I'll shift down 1. From the second point, I'll move left 2, reflect across the x-axis. This point is 3 places above the x-axis, so its reflection is 3 below. 1, 2, 3. And from here, after the reflection, I'll shift down 1. Our third point will shift left 2. Reflection, it's on the x-axis, so there is no reflection, and down 1. Our final point, we'll move it left 2. There is no reflection when you're on the x-axis, and down 1. And then from there, connect your points. The final transformation, the final function says identify and sketch the parent function, then describe the sequence of transformations and use F to sketch the transformation. I notice that we have the factor x minus 4 squared. That tells me that the parent function is x squared. So the parent function is y equals x squared. So if we graph that, if you're not very familiar with the parabola yet, remember just plot a few points. If I plug 0 in, I'll have an ordered pair of 0, 0. Plug in 1, 1 squared is 1, so 1, 1, and negative 1, 1. And I'll try one more. 2 squared is 4, so ordered pair of 2, 4, and negative 2, 4. Alright, I'm going to do my best to connect these. I'll change the color so you can see a little better. I'm afraid this is going to make a, yep, it's going to make a straight line instead of a curve. So let me go back to a pen, and I'll do my best to connect this with a curve using the mouse. It's not too bad. Okay, so this reflects, this have several transformations here. Remember the first one? And if you want to pause it and see if you can put the transformations, list them in order first, that'd probably be a great idea. The first transformation is inside parentheses right here. So that tells me to go right 4. The second transformation, we do all stretching and shrinking second, so multiplying by 2. So 2 times the y coordinate. And then 3 on the outside, if you see the plus 3, that would be shift up 3. So let's make those moves now. Again, my final move will be in purple. So here we go. I'm going to start with the origin. I'll move it right 4. 1, 2, 3, 4. The y coordinate is 0, and 2 times 0 is 0, and then I'll shift it up 3. 1, 2, 3. I'll take the ordered pair 1, 1, and I'll shift it right 4. 1, 2, 3, 4. Its y coordinate is 1, and 1 times 2 is 2. And then from there, I'll shift it up 3. 1, 2, 3. Now we'll take the ordered pair 2, 4, and we'll follow the transformation sequence. Move it right 4. 1, 2, 3, 4. Then we'll do the stretching. So we'll multiply the y coordinate of 4 by 2. That'll move it to 8. So we're at 4, 6, 8. And then the final sequence in the transformation, the final step in the transformation sequence tells me to move it up 3. So 2, 3. I know that parabolas are symmetrical across the axis of symmetry. The axis of symmetry goes through the vertex. So here's our axis of symmetry. I have one point to the right of the axis. I should have one to the left. I have a point 2 places to the right, so I should have a partner 2 to the left. And then from there we'll sketch it. All right. Thank you for watching. I hope this helps you with doing more than one step in a sequence of transformations.